Hey, what's up, guys? It's been a while since I uploaded a system design interview, so I figured I'd get back to it and upload one today. And I'm going to approach this problem. This is something I've never seen before, and I would approach it as if I was doing the interview. So this will help you get tips and ideas on how to improve your system design interviews. I'm going to walk you through the thought process as well as the steps and the calculations that I do in order to get to my final answer, and sort of just show you how I would approach the system design interview. So if you haven't done so already, hit like, hit subscribe. You know the deal. It helps the algorithm recommend my videos to more people that might need it or might want to see it. It also just gives me feedback. I asked in every video, but I wanted to throw that out there. If you haven't done so already, hit the subscribe. It literally takes like 2 seconds, and I greatly appreciate it. So let's get started. This video, I'm going to do a system design interview about a Yelp proximity service, or also something similar to Find My Friends. So first, we should sort of understand what the system is for. So let's think about this as a nearby restaurant finder. And we need this system because let me fix this typo. We need this system because imagine we have millions and millions of data points on the on the grid of the world. And in order for us to search for a specific restaurant around our location, we would have to scan all of those records and then filter out the ones that match our nearby radius and exclude the ones that don't. So this is a really costly search, and we don't want to do that every time we search for a restaurant. So to understand this, we would have to define a set of requirements. And the requirements will be that this will be able to be queried in under 100 milliseconds and is a tier 1 service. So this means that there's minimal downtime and very low latency. So this sort of boxes up a couple of ways that we can approach the problem. Let's say we have to handle 500,000 data points. We need to be able to query in under 100 milliseconds, and then we can have to also handle 100K queries per second. This is a rough estimates of what we need to do. So this will give us an idea of the system we need to build. So after defining the requirements for this problem, let's get a little bit more context of what exactly this is doing. So let's go to world map. So if we lay out the world in a map like this, we will have a better idea of what exactly is happening. So let's say we have a person, Paul, and he's located in New York City. So when Paul searches for nearby restaurants, there's two ways that we can do this. A, we can search everything that exists inside of the map and then filter out the ones that are nearby to Paul, which is the first pass, and then do a second pass to filter out the ones that match his criteria. So that's a very costly search, because that would mean we would have to go through every single restaurant inside of the entire world. And that doesn't make a lot of sense, because we need it to be fast and we need it to be, we need it to scale to a lot of people. So option 2 is we can break it down so that we only search for the restaurants that are nearby to Paul. So what I mean by that is that we narrow down the search radius and only search for restaurants in New York. So how do we do that? That's exactly the system that we're building. So now that we understand the problem more, we can go ahead and start going to the next step, which is defining the database schema. So this is sort of how the data is stored inside of the database. And we need to define like what exactly a restaurant has. So a restaurant has an ID, which is 4 bytes. And then it also has a longitude and a latitude, which are both floats and ends up being 8 bytes. After that, we need a name, which comes out to be a varchar, which let's say is 256 bytes varchar. And then we also need a description, which is let's say 1024 bytes varchar. And then we also need a category, which is 1 byte. And a category is sort of like an enum, which handles like 256 different types of categories. I don't think there's that many types of restaurants, so 1 byte is enough. 1024 handles 1024 characters. 256 handles 256 characters. And then let's go ahead and add these together to figure out how many bytes are in a record, and a maximum of 3101 bytes in a record. And then we have 500,000 data points. So 1301, that comes out to 65 million data bytes, which divided by 1024 divided by 1024 comes out to 620 megabytes. So this is a lot, but it's not impossible. We could store this in memory. However, still scanning through 620 megabytes every time you search is a little bit excessive. So we should start thinking about different ways that we can make this better. So now that we have the database schema, we should start defining what a search API looks like. So this is defining the API interface, and the first step should be, let's just define what search does. So search will take a location, a radius, a name, search, and a couple other parameters, and depending on that, return a certain number of results. So let's assume that we're querying in an internal network and authentication is already handled for us, so we don't have to authenticate the API. If we did, we could just pass in an API key, or we could also pass in an OAuth token. Both of those would work, but let's focus on the other search components. So latitude, which is a double, longitude, which is a double, search radius, which is a double. And what do I mean by search radius? So the way that distance searching works is you have a central point, and depending on how far away a point is from the central point, we can define a radius like this. And this radius is calculated by using the Euclidean distance, which is square root of a squared plus b squared. And if an item exists and it's inside the radius, then inside of this Euclidean distance, then we would be able to, that would be defined as within the radius. If it's greater than the radius defined, the Euclidean distance between the center point and the point being tested is greater than the radius, then it would be outside. So that is important because that limits how big the search actually is. A very large distance, a very large radius will return a lot of results. A small radius will return smaller results because it's less likely for multiple restaurants to be in the same location, or in a very tight